Hello, my name's Nicholas Smith.
I'm Tom Dahl.
And this is our 154 and 106 joint project.
This is our Smart Logic door, which is a bathroom door with that you don't have to touch because bathroom doors are disgusting, and we decided to skip that step.
So one thing that we had in mind is we wanted to increase the mobility for the handicap, and as well as cut down in germ contraction, which can cause sicknesses and things like that to spread. So the main sensors that we have for this door are the capacitive sensor, which is located in the center of the door assembly, as well as the knock sensor, which is a piezo speaker, which is also within the door itself.
We also check the occupancy of the bathroom to prevent unwanted walk-ins with two lasers.
So first, we will show you the capacitive sensor and its function. It plays a large role within our design because we don't want any contact with the door. So the capacitive sensor is just actuated from either side by just placing your hand near the door, and there's no contact needed. I was about an inch away from the door right now. One thing that we can alter is the delay. Say it's an old lady walking in, we could change that delay and allow for more time for the user to come in.
Another method for entering the bathroom is to knock on the door. So if you don't know if the bathroom is occupied or not, you simply knock on it and it opens.
Knock right about here, and it will actuate. Another thing that we definitely had to keep in mind is safety for the user. So if the door is opening and closing, we definitely don't want to have the door push through them. So what we can do is have a stall detection system, and this was done by using basically coating with the magnetic encoder, which is attached to the motor. So first, I will show the stall detection by actuating the door with the capacitive sensor. So notice that it returned to its original position. This will also work coming back from the closed position as well. So we'll allow it to delay, and then I will pause it halfway through, and it retracts back. It will delay again and run through the motions of closing the door.
At which point it will once again open regularly.
Yes.
Our system is powered by a 12-volt supply from a converted laptop charger and a 9-volt supply for the Arduino.
And then, so right here, we can see our two LEDs, which send over a beam, or not LEDs, two lasers, which send over a beam to the photoresistors, which the photoresistors form a voltage divider, and we are basically measuring the change in voltage between those when the beam is crossed.
We use that to check the occupancy of the bathroom. If somebody crosses the outer one and then the inner laser, then we'll consider the bathroom to be occupied. And if the inner one is triggered and then the outer one, then we will consider the bathroom to be unoccupied.
To drive the motor, we have a motor driver which can source up to 2 amps of current. It's the L298 H-bridge based. For the motor, we have a 26 RPM 12-volt motor with a magnetic encoder, which is crucial for having, basically we want functionality of almost like a servo.
The interior of the door houses our capacitance for the proximity sensor and our speaker for the knock sensor, and the LED, which will display whether or not the bathroom is occupied should somebody knock on it.
The Arduino that we used is the Arduino Mega. Unfortunately, we did start with a Arduino Uno. However, we had a minor power failure and it caused our Arduino to be fried, as well as a damaged motor. Once again, this is the Smart Logic door project for ME 106 and 154 joint project at San Jose State University. I'm Nicholas Smith.
I'm Tom Dahl.
And signing off.